Hey class, this is going to be homework helper number 4. So I'm just going to be going over various problems in there. So let's try number 3. Number 3 says f is a function that takes a real number x and performs the following 3 steps in the order given. 1. Divide by 4. 2. Add 3. And then 3 multiplied by 2. So we know that it's going to be our f function. And so we need to divide by 4. So I take that x and I divide by 4. Then I need to add 3. So I take that and I'm going to add 3 to it. And then I'm going to take multiply it by 2. So I'm going to take the entire thing and multiply it by 2. And so then when you distribute that through, you're going to get 2x over 4 plus 6, which is going to be x over 2 plus 6. And so that's going to be a function that represents that. Let's try another one. Let's see. Let's try 9. Okay, so number 9. It says f is a function. Okay, so first step, take the square root. Then it says make the quantity the denominator of a fraction. So make this the denominator of a fraction with the numerator being 4. So that's going to end up being the denominator and 4 is going to be the numerator, and then subtract 13. And so that's going to be my answer. Now in part of these it does say express the domain. We're not going to talk about that just because I know we did talk about the domain when it came to the first parts of our homework. We're going to be following up with the domain and how to find that up in the second part. So I didn't talk about the domain in this part, but I want you guys to come back to it later once we covered that part of the domain. Okay, so exercise 11 through 18 is the same as 19 through 26. So we're doing the same thing. I'm going to do 19 through 26 because it seems to be a little bit more complicated. So we'll do a few of those. So let's try number... let's do number 19. So it says my f of x equals 2x minus 5. So the first thing that it wants me to find is f of 2. So that means I just plug in 2. So that's just going to be 2 times 2 minus 5, which is going to be 4 minus 5, which is negative 1. Let's try one that's a little bit more complicated. What about 2f of a? So that means I'm going to take 2 and multiply it by my function with a as its input. So that's going to be 2 times 2a minus 5. And so that's going to be 4a minus 10. When it says f of a divided by 2. Okay, on that one. I take my function f, plug in a, and divide everything by 2. So I get 2a minus 5 over 2. And nothing reduces, so you can just leave it like that. That's fine. F of... We'll try this one. F of a plus f of 2. So that's going to be... Here's f of a. So that's my function with a plugged in, and then plus my f of 2 we set up here is negative 1. So that's going to be 2a minus 6. So that's going to be my answer. And for the last bullet point, if we're saying for number 19, if we're going to say f of x equals 2x minus 5, what if I wanted to find f of a plus h? That means that if I have f of blank equaling 2 blank minus 5, if I'm inputting a plus h into there, this is going to be 2a plus 2h minus 5. That'll be my result there. Okay. New problem. Number 29. So it says use the function f to find f of 0 and solve for f of x equaling 0. So when we're trying to find f of 0, what does that mean? And when we're trying to find f of x equals 0, what does that mean? Okay, so when my x is plugged in as 0, where my x value is going to be 0, this right here is going to be the value that is on the y-axis, right? When x equals 0, that's the value on the y-axis, so that's going to be my y-intercept. When I set my y equal to 0, right, this is y equal to 0, that's going to be my x-intercept. So basically what it's asking me here is to find my y-intercept and to find my x-intercept. So for number 29, when it says f of x equals 2x squared minus 6, when I'm trying to find x equals 0, okay, so that's going to be 2 times, so f of 0 is 2 times 0 squared minus 6, which just equals negative 6. When I set this equal to 0, if I say f of x equals 0, that means I take my function and set it equal to 0. So now I need to solve for x. I'm going to add 6 to both sides. 2x squared equals 6. Divide everything by 2. X squared equals 3. Square root both sides. X equals plus or minus root 3. And so those are going to be those values there. Let's talk about number 35. It looks more complicated than it actually is. So the idea here on number 35, I just want to talk about it and I'll let you guys to kind of think it through. When you see this type of situation, this is a piecewise function, and the way that piecewise functions work is this graph exists on this given domain. This graph exists on this given domain, and this graph exists on this given domain. So when you're given a value, you have to plug it in to the corresponding domain that it says. So f of negative 4, is negative 4 less than negative 3? Is it between negative 3 and positive 3, or is it greater than 3? Well, negative 4 is going to be less than negative 3, so I'm going to plug my negative 4 into that function. Whereas if I had 3, do I plug in 3 into this one? Well, no, because 3 is not less than or equal to negative 3. Do I plug 3 into this one? It would be yes, because 3 can be less than and equal to 3. 3 cannot be greater than 3, so it can't be that one. So I'd have to plug in my 3 into this function, etc., etc. And so you have to go through and you have to compute which one do I have to plug it into. And the same thing goes here. You're going to take these values and you're going to plug them in into those corresponding ones, and you have to decide which one is going to work when it's based on that. Alright, so now the next one, it says 37 through 62. Find the implied domain. So this is where now, after going through this lesson, you can go back to those previous ones in 1 through 10 and determine what's my domain and what's not my domain. So on number 39, it says x minus 2 over x plus 2. Now in the lesson, as a recap, we said that there were two things that we talked about that could give an issue when it comes to a domain. One of them is a rational value, meaning I can't divide by 0. And so if it's a possibility that there's a value for x that I can divide by 0, you have to say it can't be that value. The second one was a radical. And so we said that the numbers inside the radical have to be positive, because if they're negative, then we get a value in our domain in which is going to be imaginary. Well, we can't do that because our domain has to consist of real numbers. So in this case, I notice that I am dividing by a value. So because I'm dividing by a value, this is going to be one of those things where I have to say, okay, I can't. So I'm going to say x plus 1 cannot equal to 0. Minus 1 on both sides, x cannot equal negative 1. Now, there's no other restriction. There's nothing there saying that x can't be everything else. And so at negative 1, it has to be an open circle. And then I can shade in everything else. So my domain is going to be negative infinity all the way to negative 1, union from negative 1 all the way to positive infinity. And so that would be my answer for that one. Let's try another one. What if I had Ooh, 58's really good. This is the square root of x minus 7 plus the square root of 9 minus x, and I'm trying to find the domain. Now we said we can't have a negative number inside of our square roots, either of our square roots. So I have to set this one being greater than or equal to 0, because that's stating 0 or positive numbers, and this 9 minus x is going to be greater than or equal to 0. And my answer is basically going to be where the values intersect. Where do they overlap? So if I were to solve for x here, add 7 to both sides, and I'm going to get x is greater than or equal to 7. And then for this one, if I add x to both sides, I'm going to get 9 is less or is greater than or equal to x. So on a number line, if I were to graph this, the first one, here's 7, here's 8, and here's 9. So for 7, solid circle, x has to be greater than or equal to that, so I'm going to shade that. Then for this one says 9 has to be my greatest number. Okay, so I do know I have a closed circle on 9 because of that, but x is less than that. So at this this closed circle here, if I shade everything less than that, I get this. So my domain is where those two values overlap, and so my domain is going to be from 7 all the way to 9, and that's going to be my answer. Let's take a look at another one. Ooh, let's do 50. There's a reason why I want to do 50. Alright, so let's take a look at this. So we know that 6 over the square root of 6x minus 2. So there's two things going on here. One, I can't divide by 0. Two, I have a square root. Can't be negative inside of it. So I could just say, well, I know that 6x minus 2 has to be greater than or equal to 0, but we know it can't be a 0, so I can just get rid of that equal to. And then from there I can just solve for what my x is. So add 2 to both sides, divide both sides by 6, and so I'm going to get x is greater than or equal to 1/3. So now if I wanted to create a number line with that, here's 1/3, it's solid, and it's going to go on to infinity. And so at 1/3 and then to infinity. And that's my answer. Let's take a look at another one. So on 64 it says the area A enclosed by a circle in square meters is a function of its radius r. When measured in meters, this relation is expressed by the formula AR equals pi r squared for r is greater than 2. Find A of 2 and solve when A of r equals 16 pi. Interpret your answers. Why is r restricted to being greater than 0? Ooh, good one. Alright, so let's go over it. So it says we know that our formula A of r has to be pi r squared. It says find A of 2. So that means that I have to plug in 2 into my equation. And so I'm going to get 4 pi. That's my answer. Then it says solve A of r equals 16 pi. So I'm assuming it wants me to solve for what r is, because it said that there's no r there. So if I know A of r equals 16 pi, and I know that A of r equals pi r squared, I can set them equal to each other. Now I need to solve for r. So if I divide both sides by pi, those cancel out. Square root both sides there, I get r equals plus or minus 4. And so r is only going to equal 4 because it says right here that for r being greater than, whoops, sorry, wrong one, r being greater than 0. So because r has to be greater than 0, I have to only use the positive one. Now it says why is r restricted to being greater than 0? Okay, if I have a circle with a radius of r, what does it look like when you have a negative radius? I mean, it's either you have a radius that goes out in some value, or you don't. It's just a dot, right? That's technically a dot is the area of no radius. So you can't have a negative radius. That's just, even conceptually, that's just kind of weird. So just some things to think about. And I think that pretty much goes in at these examples we talked about in class, so we went through a lot of those things. So great. Well, if there are any other questions that you guys see in here, please approach me and let's talk about it in class. Other than that, hope you guys have a great day. If you have any other questions, please leave them in the comments.